Good morning.
Good morning.
Okay, so Nathan, I see name. Okay, Iran, Tima. Okay, so Andrew, Tima, I saw her name. Lorraine,
Here.
Okay. Lynn,
Here.
Juanita, Iran,
Here.
Gabriel, Divina,
Here.
Kobe, Chantal,
Here.
Gongsi,
Here.
Kyle,
Here.
Matthew,
Here.
Julian,
Here.
Alejandro.
Here.
Do we have any person whose name I did not call? Okay. What about today? I'm going to solve more problems, and if I have time, I am planning to talk about graphs and properties of some of trigonometric functions. This is like my plan for today. So this why I am going to right now tell you about the page number and numbers, and you probably can choose your problems from this spot. And I'm going to use your textbook. And we were on page 364, right? As I remember.
Yes.
Yeah. And this is the, what about the page here? Yeah, where is number 20? Right here. Number 36 on that page was the last one which we worked with. Is it correct?
Yes.
Okay. So let's look at another spot. By the way, would you like to ask me to solve any other problem from 34 to 37? I'm talking about equations.
I think we're okay.
Okay. So can you please look at bigger spot from 38 to 53, please? And what should we do here? We need to determine if these equations, which we have from 38 to 53, are identities or not. We already worked with problems with identities, and even though, let's say, left side and right side, from the first glance, they look absolutely different, mathematically, they are equal to each other. So basically, in these problems from 38 to 53, you can have same approach. You can start with one of sides And if you can, after certain steps of simplification, you can come to the expression which exactly matches the other side, you can positively answer that, yes, it is an identity. Okay, let's, for example, look at problem number 40, and it is not a trigonometric. It is not a trigonometric problem. It is coming from pure algebra. I'm going to copy right now this problem, and we will go from there. What do we have in this problem? We have a square root on the left side, and the radicand under this root is a difference of two squares. So number 40 has square root of 64 minus x squared equals 8 minus x. And we need to analyze what we have to see if it is an identity or not. What do you think about this equality? I can call it like equality because it has an equal sign. Any mathematical sentence with equal sign is equality. It doesn't mean it is true or false. If it is true all the time, it is an identity. If it is not true all the time, but can be true for some values of x, let's say, which we have here, it will be an equation. So, can we break square root of 64 minus x squared into difference of 8 and x? What do you think?
Yeah.
No, guys, we cannot. Because I'm going to write the formulas. Square root of a times b, it is absolute value of a times absolute value of b, one formula. If you have square root of the quotient, it will be also quotient of the first powers with absolute values. Why I'm using absolute values here? Because let's say if A and B are both negative, product will be positive. Or let's say quotient of two negatives is also positive. But when we need to simplify, we can take out of a symbol of the root non-negative values. This is why I have here absolute value symbols. But when we have a sum or difference, and I united two things in one piece. You can see you have here n plus and minus. So once you can read with the top sign, once you can read with the bottom sign. It is not equal to square root of a plus or minus square root of b. We cannot break sum or difference under the root sign into sum or difference of two roots. So basically, if you need to prove, let's say you can start with the left side here. Left side here is square root of 64 minus x squared, which means 8 plus x. I'm going to show it right now. 8 minus x. You can break this into product of sum and difference between 8 and x. And this is the square root of the product. So we can apply this formula, which I showed right here on the top. So which means, I'm going to separate that formula. So I'm talking about that first top formula. and which means it will be absolute value of 8 plus x multiplied by absolute value of 8 minus x. And it is absolutely not matching what we have on the other side of the original problem. So it is definitely not an identity. It is not. Let's have something with trigonometry. Are you okay with number 48?
Yes.
Yes.
Yeah.
Okay, let's write it down. 48. 48 is sine x multiplied by tangent x, and the other side is it okay that instead of cosine x parenthesis squared, I will write what we more often write for that in math? It is cosine square x.
Yeah.
I'm a little bit surprised that they wrote this in that way, but it is not a mistake, definitely. Cosine x in parentheses squared. If we do not have parentheses around cosine x, it means, and we have that squared, so it will be cosine of x squared. It is not going to be cosine squared. But if you write down cosine square x, it means square of cosine x. This is an international approach. This what we can write, which looks better mathematically. Sine x times tangent x equals to 1 minus cosine square x over cosine x. Which side would you like to start with? Left, right, I do not mind.
Right.
Okay. Right side, right side. What do we have on the right side? Is it a fraction?
Yes.
Yeah.
What do you think about the top? What about the top expression, which is 1 minus cosine square x? Can we simplify this using any trigonometric formula?
Yes, you can simplify it to sine x squared.
Absolutely correct, because you actually originally had in your mind what kind of formula? Sine square of
Sine
x
squared plus cosine.
plus cosine square of x equals to 1, right? And if you solve it for sine squared, you will get exactly what you have in this fraction on the top. So the top is sine squared x. The bottom is cosine x. This what we got. But so far, it is not matching what the expression which we have on the left. But sine squared x, is it square of sine?
Yes.
If I have a squared, if I like, can I actually separately write this like a times a instead of a squared? Yes?
Yes.
So this is what I'm going to do with sine square x. I will write that it is sine x multiplied by another sine x, and I will copy the denominator. And look what I'm going to do right now. I will separate, and I am surrounding these terms which I'm going to separate. Can you see what I did?
Mm-hmm.
Yeah.
Is it sine of x multiplied by what I surround by funny shape, right?
Yes.
So practically, can we write that it will be sine x times fraction, which is sine x over cosine x? Sine x over cosine x can be changed into something different. And what can you recommend me to write instead of that?
Tangent x.
Absolutely correct. Should I stop right here and say that basically I proved that it is an identity?
Yeah.
Yes.
So write it down that we actually proved that. And because we proved that, this is an identity. Do you remember the symbol of that square? The meaning of that square?
Yes.
So which means we proved. Do you understand how to work with these problems?
Mm-hmm.
Yes? Okay. Okay, just let me see if I see something more interesting here so far. Just let me look at another page, just 1 second. I'm going more further. Okay. Not really. Maybe in a review exercises we can find. Yeah, definitely everything is quite interesting. But where is the review? In this chapter 9, we have another very important material, which will be practically a new material for you, and I'm planning to review. You know what? Yes, I found something nice on page 395. 395. On 395, we have other identities here, not too many, from 35 to 38. I really like to offer you right now number 37. Are you okay with that number 37?
Yes.
Yeah.
Yeah.
Can you copy, please, that problem? And
What page?
again on page 395. We have sine to the 4th power minus cosine to the 4th power equals sine, and on the other side we have sine squared x minus cosine squared x. This is quite nice, but honestly quite easy problem. And what should we do here? We need to prove this identity. Which side looks more complicated to you?
Left side.
Do you remember my recommendation to start all the time with that side, which looks more complicated?
Yes.
So which means, because left side is more complicated than the right side, I'm going to start with the left side. And what do we see on the left side? Right above this original identity, I will remind you something from algebra. A to the 4th power minus b to the 4th power. Fourth power, is it a square of square?
Yeah.
Yes.
Excellent. In this case, can I treat a to the 4 minus b to the 4 like square minus another square?
Yes.
But only it will be square of a squared minus square of b squared, right?
Mm-hmm.
In other words, again, 4th power is a square of square. I even write down I wrote down this in that form. Square of a squared minus square of b squared. Can I treat now this like a difference of two squares?
Yeah.
Yes.
That's it. Let's factor it. So it will be a squared plus b squared times a squared minus b squared. Is it correct?
Yes.
Agree?
Yes.
Yeah.
Okay, let's do that. Only now for us, sine to the fourth power of x is sine square of x, parenthesis squared, and cosine to the fourth power can be treated in the same way. So let's write it down. Sine square of x squared and apply that formula from algebra. So it will be, so far we are using only algebra. Are you okaying what you see on the last line?
Yeah.
And now I think it is time to apply trigonometry. Do you see in each of these parentheses something very attractive which begs us to apply trigonometry? Guys? Hello?
The identity.
Excuse me?
The identities.
Yeah, just apply any formula from trigonometry which can be used here. What do you see in the first parenthesis? Is it sine square of angle x plus cosine square of angle x?
Yeah.
Yes.
What is it equal to?
1.
Definitely, it is 1. It is 1 times that second parenthesis. Actually, I can simplify the second parenthesis as well, but there is no need because I'm proving an identity. So if on the previous line I had sine squared x plus cosine squared x times sine square root of x minus cosine square of x, now it is 1 times the second parenthesis. Is it equal to sine square x minus cosine square x?
Yeah.
Yes.
Is it what we had in the original problem on the right side?
Yes.
Are we done?
Yes.
With the proof? Yes. Please place that square because we proved this problem. Definitely. Randomly, we will be forced to solve other problems as well. And on page 394, I see something different right now also, and I really recommend you to look, let's say, at the problem number 20. Problem number 20, which is not an identity anymore. It is a trigonometric equation. Would you like to solve this together with me?
Yes, please.
Yeah.
Okay. Number 20. On page 394, 3 sine squared alpha It is not A, it is alpha. It looks slightly different than A, but it is equivalent of letter A in the Latin alphabet. It is alpha, 3 sine squared alpha plus 4 equals to 5. Can you please critically look at this problem and name it from algebraic point of view? Definitely, it is a trigonometric. Do we have here square of sine of alpha?
Yes.
Yeah.
Can I say that it reminds me the shape of quadratic algebraic equation?
Mm-hmm.
But I cannot say that it is a quadratic equation because it carries the symbol of trigonometric function. But can I say that this is a quadratic equation with respect to sine alpha?
Yes.
Yeah.
Yes, we can, definitely. This is why we are going to treat this at the beginning as I would treat any quadratic equation, which is, let's say, 3x squared plus 4 equals to 5. Can I move 4 to the right side?
Yes.
Yeah.
Excellent. 3 sine squared alpha. Is it going to be 5 minus 4?
Yes.
So is it 3 sine squared alpha equals 1?
Yes.
Would you divide both sides by 3?
Yes.
Yes.
Why? Because 3 is a coefficient of that. So what do you get here in as doing this? Is it equal to 1 sine squared, I mean, equal to 1/3?
Yes.
But let me read what we have to do here, because I was hoping that you already read the request here, which we had. It says, solve the equation with 0 less or equal to alpha, alpha less than 2 pi. Give exact answers if possible. Okay, we will try to do that. We got an interval. If I, let's say, don't want to write this in this form of inequality, I can write that alpha belongs to semi-closed interval from 0 to 2 pi. This is one revolution. You can see one end is locked, which is 0 end. 2 pi is an open end. It's okay. But now, should I take square root from both sides to find sine alpha in the first power value?
Yes.
Let's do that. And if you take square root from both sides, do you get plus minus 1 over square root of 3?
Yes.
Or plus or minus square root of 3 over 3? They ask us to find approximate value. If I had here tangent or cotangent, I would not have any problems immediately recalling values of quadrantal angles, trigonometric functions, and values for reference angles like 30 degrees, 45 degrees, or 60 degrees, or their equivalents in radians, because we have values for tangent and cotangent of these angles exactly equal to square root of 3 over 3. But it is a sine alpha. This is why we do not have in these tables of values any exact value provided in these tables given for sine alpha or cosine alpha. What should we do? First, we need to know if this problem is solvable So we call them consistent problem. In other words, it has a reasonable answer, because there are so many problems where we have no solutions. This is why let's roughly estimate that value. Square root of 3, quite roughly, is about 1.7. If you divide 1.7 by 3, what do you get? The closest number nicely divisible by 3 is 1.5, so it will be already 0.5, and there is something left. So it will be approximately about 0.56 with plus or minus. Is it okay for sine alpha be approximately equal or positive 0.56 or negative 0.56? Guys,
Okay.
you did not answer my question. Yes or no? What about the range for sine alpha? Is it from interval, closed intervals, from -1 to +1?
Yes.
Yeah.
Positive 0.56 or negative 0.56. Are they in that interval?
They are.
Yes, they are.
That's it, which means yes, definitely this problem has a solution. And because it has a solution, let's try to solve it. Okay, so I'm solving. I'm going to break this into two pieces. Sine alpha equals positive square root of 3 over 3. It is part A. Part B, sine alpha equals negative square root of 3 over 3. And for each of these cases, I already know it is or approximately 0.56 and or negative 0.56. I'm going to sketch circles, which can help me to find all angles in one revolution, because alpha was chosen from one revolution only. And do you understand that in our benefits is to use a unit trigonometric circle? So R is equal to 1 for both cases. This is what I did. I prepared two circles. And I will find y value equals to approximately 0.56. So it is somewhere right here, a little bit higher than the midpoint of the top radius. And in the other case, it is negative 0.56. It is another point right there. Oops. And now I remember that in the unit trigonometric circle, sine is equal to the y coordinate of the endpoint. So I'm sketching perpendiculars to cross circles. And you can see in both cases, we got 2 points for each of these parts, and A and B. We got 2 points on the circle. These are endpoints of possible angles which can be used as answers for these equations. This is why I'm going to connect both points on the circles with the origin. And now I will show these angles. So one angle, second angle, one angle, second angle. Oops. So practically, here are 4 solutions. We need to find all these angles. If you look at part A, you can see one angle is from the first quadrant, another is from the second quadrant. If you look at part B, you see one angle in the third quadrant, one in the fourth quadrant. But look at part A at the smallest angle. This is your reference angle for this value, which we can use easily to find the rest. And because we do not have exact value, this angle alpha 1 is arc sine of that number, or inverse sine. Inverse sine has two symbols, because again, we are looking for exact value. You can write, and I am planning to review with you in inverse trigonometric functions. So I'm using an inverse function. So it is arc sine of square root of 3 over 3. It can be written, and actually this book is using these symbols. This is more modern symbol. You have more traditional symbol, because all these inverse trigonometric functions are being called arcuses. Though this is arc sine, and our textbook for pre-calculus class is using this symbol. So this is more traditional. If you did not see that, because your teachers did not show you that. Anytime when I teach trigonometry, even if, let's say, in the textbook, they are not, I don't know why, do not mention anything about this traditional symbol, I all the time tell my students about this. So this what we have. This y, oops, I can find now this second value, which is alpha 2, and alpha 2 will be pi minus arc sine of that number. This is the second value. Because if you look at the angle from the second quadrant, and this is alpha, the second. Now, let's see what we have in part B. In part B, we have the angle from the third quadrant. Can I say that actually it will be pi plus reference angle? Guys?
Yeah.
So pi plus arc sine of square root of 3 over 3. And now, can you look at the last angle, which is in the fourth quadrant? Can I say that it is 2 pi minus that reference angle?
Yeah.
That's it. So it will be 2 pi minus the reference angle, which comes in the form of the arc sine of square root of 3 over 3. So this problem has 4 exact solutions. Definitely, you can enter this into your calculator to approximate. They say find the exact value if it is possible. We found all exact values. If you like to approximate, you just need to enter these symbols into your calculator. Don't forget to have your mode in radians. I'm not going to put much stress on this part, because actually I am planning to talk about this just a little bit later. And that's it. And this is again about usage of inverse trigonometric functions. Now, quite quickly, I will talk about property in graph of y equal to sine x, because we have modified formula, and I will write down starting with modified formula. So you can write down the subtopic, and we mainly will be working with this type of graphs on coming Monday. Don't forget that I will be offering you so-called in-class quiz, and how I am going to do that. I am going to do that in the same way as I offered you the test, which we had not long time ago. Do you understand what I'm talking about?
Yeah.
The only that quiz will be not for entire meeting. And probably I will offer it to you in this second part of the class, finishing with that quiz. And so we can say goodbye to each other, and you will go to the Wiley Plus and you will take that quiz, which will be for about 20-25 minutes of work. Is it clear?
Yeah.
Yeah,
It will
What day is this?
excuse me?
Monday.
Oh, Monday. Okay.
On this coming Monday, yeah. Because we already had quite many topics which we reviewed from trigonometry, and again, trigonometry is not your brand new material. So what I'm planning to offer, I will plan to offer you one expression which you have to simplify using properties of trigonometric functions. Probably, definitely I will offer you an identity and an equation. Okay, I'm going to write right now modified formula for the family of sines. And this is that formula. Y equals A times sine brackets omega times parenthesis x plus phi. This is letter phi. And at the end, you see letter of Latin alphabet, K. Here we have the following parameters: A, omega, phi, and K. Each of these parameters plays its own role for this function. Coefficient A, because we are talking about the member of family of functions in the sine family, it is responsible for the amplitude. A is not amplitude itself. A with the absolute value is the amplitude, because that A can be positive number, it can be a negative number. Amplitude never can be equal to any negative number. Why? Because amplitude for this family is the half of the entire height of the graph. Amplitude is 1/2 of h. H is the height, entire height of the graph. Next here is omega. What about omega? Omega is responsible for the period, because if we know the value of omega, we can use that formula 2 pi over omega to find a period of the given function. What about that phi parameter which you have here? This is the parameter which is responsible for horizontal shift. We can say horizontal shift, we can say phase shift. Two words are synonyms, phase shift or horizontal shift. Let's say phase shift. Be careful, as any phase shift, you can write that it will go into direction opposite for phi. Let's say, again, we just can assume to simplify the process, because if we do not do that, we need to consider different values for phi, and positive and negative and zero. Definitely, if it is zero, there is no phase shift. Let's say phi is a positive number. Let's say in parentheses, we have x plus 2. So phi is 2. In this case, phase shift will be going into negative direction. So it will be 2 units to the left, into direction opposite to that sign which you have in front of phi. So which means you can write that this will be phi units to the left, or you can write that it will be minus phi. So which means into direction opposite to that phi sign. The last parameter at the end is responsible for so-called vertical shift. Again, if it is 0, there is no vertical shift. But this time, vertical shifts are going into absolutely same direction as you have with k. So if, let's say, we assume, because in this case, I again need to talk about possible values of k, let's assume that k is positive. It doesn't mean that it will be positive all the time. It can be positive, it can be negative. So if it is positive, a positive number, the vertical shift here is k units up. Or you can write plus k. Definitely, if k is negative, it is like an elevator, will bring graph k units down. So this is what we have. This why, if we talk, let's say, about such a basic function from this family, like y equal to sine x, looking at that moderated formula for entire family, what can we say about that particular function? A is positive 1, omega is positive 1, phi is 0, and k is 0. This what we have, this is a set of values for all parameters. Can we say so?
Yes.
Yes.
Does it mean that there will be no phase shift and no vertical shift?
Yeah.
Please write it down. That this function does not have phase shift, or if you like, you can write horizontal shift, nor vertical shift. But what should we say about now this family, this particular function? I need to list some main properties. First of all, domain. Domain of that function is set R, because we are talking about here of x as an angle given in radians. Any real number is okay as a value of x. So domain for all family members of sine is set R. So now we can find the amplitude. Amplitude is absolute value of 1, which is 1, which means half of the height of the graph is 1. So entire height will be 2 units. If we know the amplitude and we know information about vertical shift, none. Having these two pieces of information, we can write down precise information about its range. In this case, because entire height is 2 units and there is no vertical shift, it will be fluctuating between -1 and +1. So this is the range of that function, closed interval, or we can say a segment, -1, +1. And you can write it down. Another piece of information which is extremely important is a period. And period here depends on value of omega. Value of omega is 1. So 2 pi over 1 is 2 pi. So sine x here is 2 pi periodic function. So I don't have time right now to show a very good looking graph, but if you do not use graph paper, the best thing for graphs is definitely to use graph papers. But if you don't use it, it's okay also. What do? First, you need to remember, because this function is periodic, you need to show the graph in at least 2 cycles. The length of each cycle is equal to the period. So this why I will immediately on my graph will show 2 points on x-axis, which are negative 2 pi and positive 2 pi. And after that, this is my recommendation for everyone, for all functions in trigonometry, not just sine. Immediately, each time when you show one cycle or second in 2 cycles, divide each cycle into 4 congruent pieces and label. So it will be, I will show it right now, just 1 second. And you, I think, already did that kind of things. You have to label each point. So in the middle, between 0 and 2 pi, you have pi. In the middle, between 0 and pi, you have pi over 2. In the middle, between pi and 2 pi, you have 3 pi over 2. Basically, we see here all 4 quadrants. And do the same thing on the other side. The only difference is on one side, we have all positive values. On this, at these points, on the other side, they are all negative. After that, if you do not use a graph paper, if I were you, I would show 2 horizontal lines. One is running through y equal to positive 1, another running through negative 1. Limiting the space to show that entire graph will be between these 2 dashed horizontal lines. And because our sign is very specific, sign at 0 is 0. If it is a basic sign with no phase shift, it all the time will be running through the origin. I made that origin quite dark. And after that, it will be reaching its maximum at pi over 2, reaching 0 level at pi, reaching its minimum at 3 pi over 2, and finally coming back to 2 pi. This is your graph in one cycle. Now just spread this to the other cycle. Difference between similar values of y will be equal to 2 pi. So from 0, if you go to the left on the distance of 2 pi, it will be at negative 2 pi, it will be 0. From pi over 2, if you go again 2 pi units on the left, you will be reaching maximum at negative 3 pi over 2. From pi, you need to count 2 pi, which means 4 times of smaller pieces. You are at negative pi. And so far, I am showing all these points right here. And now you just need to connect them with another wave. Smooth wave, no sharp ends, please. And right here, you have the graph in 2 cycles. That's it. Did you have an opportunity to finish this graph?
Yes.
Yes.
Yeah.
I think it looks very familiar because you did it so many times. And definitely on the coming Monday, we'll be talking about more complicated formulas, not just for simple sine x, and how to apply these all shifts, vertical, horizontal, how to change the range if we have vertical shifts, and etc. I have another meeting right now. This is why I need to tell everyone goodbye. Have a nice weekend. and do your work, and you should have your online quiz as well. Okay.
Okay.
All right.
Okay, guys, have a nice, beautiful weekend. Okay.
Okay,
You too.
bye-bye.
Bye.
Bye.